Hello. Hello. Today I want to discuss two subtopics in EDEXCEL Physics Unit 1. So welcome to this presentation. Two topics, like I said. The first question here is on vectors, and the question says a box of weight 150 newtons is placed on an inclined plane. The component of the box weight acting along the plane is W prime, and the question is W prime in Newton is given by, then you're supposed to complete. So this is basically a multiple choice question that requires you to have the knowledge of vectors, resolution of vectors. So in an inclined plane, there are usually two main forces. There is a reaction force that is perpendicular to the plane, which is a component of the weight, and that is usually given by weight times cosine of theta. And then there is a force that is parallel to the plane, that is W prime, and that is usually weight times sine of theta. So in this particular case, that is what we need to do, is just to identify the weight and multiply by the sine of 15. And that is what, if you look at the working down here, W prime is just given by weight sine theta. So you take 150 times sine of 15 degrees, and then you work it out and you get 38.8 newtons. The second question here also deals with vectors. We're told a man is walking at a constant horizontal velocity of 1.2 meters per second in the rain. To the man, the rain appears to be falling vertically at a velocity of 1.8 meters per second. Then you're told to draw a labeled vector diagram to scale and use it to determine the actual velocity of the rain. So you have two velocities, that is 1.2 in the horizontal direction here, and you have a 1.8 meters per second in the vertical direction here. So apart from knowing the directions, you must be able to indicate the directions with the arrow accurately, and then you also need to identify that a vertical direction and a horizontal direction are at 90 degrees to each other. So with that done, you simply translate the two directions into a rectangle, which is a right angle triangle, and of course the hypotenuse of that triangle gives you the resultant velocity. So first, you can actually confirm your answer by doing it by Pythagoras theorem, because it's a right angle triangle, and you know what to do. You simply take the hypotenuse squared is equals to one of the sides squared plus the other side squared, and then you work, of course, you work out the velocity and you get 1.34. So if someone has to do it to scale, because the question says you do have to do it to scale, so you have to choose a scale that will accommodate 1.8 meters per second and 1.2 meters per second. So you should make sure that your scale does not make your figure to be too small or too big to be covered, not to fit into the space that you have. So one good example of a scale is what I've given here. Like you can say 1 centimeter to represent 0.3 meters per second. That means a velocity of 1.2 meters per second, you represent it with 4 centimeters, and a velocity of 1.8 meters per second, you can represent with 6 centimeters. So basically 4 centimeters and 6 centimeters are not very big or too small dimensions. They are dimensions that you can actually draw in your exam paper, and you measure the hypotenuse accurately. Don't forget also, you may also need to use a protractor just to confirm or to make sure that the angle between the vertical and the horizontal is 90 degrees. Otherwise, if it is not 90, the hypotenuse will not be the correct answer. So the next question is touching on the projectile motion. So you're told that in a game of netball, a goal is scored when the ball passes through a ring at the top of the net. So you have a picture there of people playing, and you have a net, a net and a ring. So basically, somebody has to throw the ball to pass through that ring for a goal to be scored. So on the diagram below, draw the path. Draw the path the ball should take if a goal is to be scored. So definitely, you have to draw kind of a curve, and that curve should actually end up inside the ring. So the answer that is expected should be something that looks like this, where the ball is a curve. It basically is known as a parabolic curve, and then it goes through the center of the net, and that would mean that the goal is scored. So drawing that should earn you 1 mark. So the next question is, a student is given the following information for a particular attempt at a goal. The initial velocity of the ball is given as 4.5 meters per second. The release angle of the ball is 60 degrees from the horizontal. Then horizontal distance from the center of the ball to the center of the ring is 1.5 meters. So then you're told, show that the time taken to travel the horizontal distance of 1.5 meters is about 0.7 seconds. So in projectile motion, you must be able to resolve the velocity into two components. The velocity usually, if a given velocity that is projected at an angle, then that velocity must have a horizontal component and a vertical component. So the horizontal component is usually velocity v cosine of theta, and the initial vertical component is v sine of theta. So with those two components already identified, our aim is to calculate the time to make sure it's around 0.2 seconds. Now, to do this, there is a knowledge about projectile motion that the horizontal component of velocity is a velocity that remains constant throughout the projectile. Okay, it remains throughout the trajectory. So that means if you are to calculate the distance in the horizontal direction, you simply need to realize that distance is speed times time, because the speed is constant. It's not affected by gravity. So that in mind, you get the horizontal component v cos theta. You take 4.5 cosine of 60, and that gives us the horizontal velocity as 2.25. And then, of course, now we are looking for time. We say time is distance over velocity. And like I said, it is because the velocity is constant. That's why we are using this equation and not the equations of linear motion. So the time there will basically be 1.5 divided by 2.25, which is 0.67, and 0.67 is about 0.7 seconds, like the question required. So the second part is also on projectile, and it says calculate the vertical displacement of the ball when it has traveled a horizontal distance of 1.5 meters, and hence comment on whether a goal will be scored. Vertical distance of the ring from the release point, vertical distance of ring from the release point 0.7 meters. So what we need to do in this case, we have been given a distance, horizontal distance of 1.5 meters, and so we are going to base our answer on the time. So we are going to calculate the initial velocity component, which is v sine theta, that gives us 3.9, and then when a ball is thrown, if you consider the vertical motion, the acceleration due to gravity is negative because it's going against direction of gravity. Then of course the time, if you're talking about 1.5 meters, then of course the time is already calculated as 0.67. And then so you have U, A, T, and you're looking for S. So you have to identify an equation that will make you get S, and that is UT plus a half AT squared. So when you do the substitutions with all the values that you have obtained, you get a vertical displacement of 0.41 meters. So then the other part of the question says, comment on whether a goal will be scored. So you have to consider something like the maximum height of the ball. So the maximum height, you take the final velocity to be equal to 0. You have calculated the initial velocity as 3.9. You have acceleration, which is negative 9.81, which is usually given, and you're looking for the vertical displacement of maximum height. So again, you identify the correct equation, and you realize that the equation that you will now have is v squared equals to u squared plus 2as, and that gives you a maximum height of 0.2 seconds. So from these two answers, the vertical displacement at 1.5 meters horizontal distance gives you 0.41 meters, and the maximum height of 0.2 meters. So that basically tells you that the maximum height of the ball is less than the height of the ring. So your comment should be that the ball will not the goal will not be scored simply because the maximum height of the ball is less than the height of the ring. So with that comment, based on the calculated answer, then you are assured of getting your maximum max of 4. So basically, that's how you tackle question on projectile motion. So the last part of this question says to explain how air resistance would have affected the calculations in part B1. So part B1 is where we were calculating the time taken. So like we said that horizontal component of velocity is usually constant. It is never changing because it is not affected by gravity. So that is based on the assumption that there is no air resistance. But if air resistance is considered, then the horizontal component of the velocity will not remain constant. In actual fact, it will be reducing, it will be less than the value calculated when there is no air resistance. So when the horizontal component is smaller than what is there, than when air resistance is not considered, you expect that the time taken for the ball to reach the ring will be higher than 0.7. So a reduced velocity will increase the time to reach maximum height, and that is basically how you look at it. So air resistance will decrease horizontal velocity, and when horizontal velocity is reduced, the time taken will be higher than 0.7. So remember, you have to base your answer, or you have to compare your answer with what was calculated in B Roman 1. So B Roman 1, if I can go back there, B Roman 1 was to show that the time taken to travel horizontal distance was about 0.7. So if you talk about a reduced velocity and then an increased time, so you say increasing mean it will be higher than 0.7. So that marks the end of that short discussion on the vectors and projectile motion. In case maybe you need more explanation on the same topics or other topics in Unit 1, Unit 2, up to A level, you're free to contact me through my email address provided here and my mobile number. For people in Kenya, Nairobi, you can call me directly for physical classes or online classes. I'll be available. For those who are not within Kenya and who need some virtual lessons, I'll be available. Thank you very much.